Okay, today we're going to start section 10.5a. I'm going to review with you guys the polar coordinate system. In the case of the polar coordinate system, all it simply has is a fixed point, which is called the pole, and a ray, called the polar axis. All it looks like is a point and a ray. The polar axis is the positive side of our x-axis, so that helps us sort of keep it in perspective, and our pole is just like our origin. We name points by using r and theta. So r represents the distance or the directed distance from the pole, and theta is the angle. Theta is what we call the directed angle going counterclockwise from the polar axis to the segment connecting the point to the pole. And then we have r as being defined as the directed distance between the point and the pole. Now we're actually going to also work on plotting. So I want us to plot, let's try 2 pi over 4, 3 negative pi over 6, and negative 2 negative 3 pi over 4. Okay, now always pay attention to the kind of grid that you're working on, because in this particular case, the one that I have, isn't marked with the x-axis or the y-axis or anything like that, so it's kind of a little trickier to do. The upper half of my unit circle is broken up into 12 sections, so each of these is pi over 12. So I want the point 2 pi over 4. I'm going to make the most use out of these circles here, so I'm going to have every concentric circle be a half unit. So if I want to plot the point 2, 4, it's going to go right over here, and I'm going to call that my point A. Now I'd actually like to also plot another one while we're at it over here. What would the point negative 2 pi over 4 be? Okay, remember what I said about directed distance. So the angle pi over 4 extends through over to the other side, but when you plot negative 2 pi over 4, you locate where pi over 4 is, and then you're going to go negative 2 from there. So you're going to go in the opposite direction. I'm going to call this point D. So just sort of a tip as to how to graph these. Always look for the angle first, and then if r is positive, you're going to go in that direction to the quadrant that contains that. If r is negative, you're going to go in the opposite direction into the quadrant behind the one that you're supposed to be in. And I want to plot the point 3 negative pi over 6. So we need to find where pi over 6 is. Okay, pi over 6 is the second line over here, but it's a negative angle. So wait, I don't actually want that one. I want it to go in the negative direction, so it's going to look like this. This is negative pi over 6. So negative pi over 6 is in quadrant 4, so I'm going to count 3 in that particular direction. So my point is going to be quadrant 4. How about plotting the point 0, 7 pi over 6? This is going to be in quadrant 3, but r is 0, so it doesn't actually matter what that angle is. Anytime you have 0, comma, and any theta, this is going to always be at the pole. Okay, let's plot this last point that we have up here. Negative 2, negative 3 pi over 4. So first thing, think about what quadrant negative 3 pi over 4 is in. What quadrant will that be? That should be in quadrant 3. Our angle is negative, and our r value is also negative. So what does that mean for us now? Well, instead of the point lying in quadrant 3, it's basically going to kick backwards and go into the opposite side, so quadrant 1. And we're going to be 2 units out, so on the 4th ring, because I'm counting every concentric circle as a half unit. We could also name point C 2 comma pi over 4. We could have even called it 2 comma negative 7 pi over 4. We could keep on adding 2 pi or subtracting 2 pi in order to get that same coordinate point. We need to work on coordinate conversion, and in order to convert back and forth from polar to rectangular and vice versa, you guys are going to need to remember how x, y, r, and theta relate. So in this case here, if I just draw a point here xy, or it could be thought of as r theta. I'm going to do two things here. This is my x coordinate and then my y coordinate. R is my directed distance to the pole. Theta is the angle created. So we can come up with four relationships. X equals to r cosine theta, y equals to r sine theta, and x squared plus y squared equals r squared, and tangent theta equals y over x. I want us to convert to rectangular form. The coordinate point, -2, 5 pi over 4. Since r is -2 and theta is 5 pi over 4, we want to find xy, which we know to be r cosine theta and r sine theta. So just plug everything in. -2 cosine 5 pi over 4, -2 sine 5 pi over 4, and then fill in the values. So hopefully you remember what cosine 5 pi over 4 is. So think about your unit circle. 5 pi over 4 would be over here in quadrant 3, so that's going to be -2 times negative radical 2 over 2, and then we have sine 5 pi over 4, which is also negative radical 2 over 2. So our answer will be radical 2, radical 2. And see if that makes sense. 5 pi over 4, which would be in quadrant 3, it is a -2. Well, that's a good thing because look where our coordinate point is. Radical 2 in quadrant 1. How about the point 3 pi over 2? In this case, 3 pi over 2 is on one of our axes. So whenever you have something like that, I really suggest you just draw the little picture and be done with it. Where is 3 pi over 2? That's over here on the bottom side of my y-axis. And you're going to count 3 spaces out. What is that point? 0, -3. So let's see if we can convert to polar form. So let's convert over the point radical 3, 1. And keep in mind, this is now an xy coordinate point, and we want to get it in polar form, which is r theta. So we can't just do a quick little substitution just like before. We do have to do it sort of on the side. So what we need to use is x squared plus y squared equals r squared. So that means 3 plus 1 equals r squared. R equals to actually a plus or minus 2, and tangent theta equals to y over x. So in this case, 1 over radical 3. Do you guys remember what angle has a tangent value of 1 over radical 3? It's going to be pi over 6. Okay, so theta equals pi over 6, but it could actually also be 7 pi over 6, depending on what quadrant you want to be in. Okay, remember this from trig, ASTC? That tells you which quadrants will produce positive trig ratio values. And all of them are positive in quadrant 1, and only the tangent is positive in quadrant 3. So I can actually include 7 pi over 6 in the mix here. Now, how do I know how to choose which r value and which theta value I'm going to use? Well, let's see. Our point is in quadrant 1. Radical 3, 1 is in quadrant 1. So I need to choose an r theta combination that's going to be in quadrant 1. So we can use pi over 6, because that's in quadrant 1. Then we're going to need an r value of 2. If you choose to use 7 pi over 6, note that that angle is in quadrant 3, so we must choose a -2 r value for that one. Again, there are infinitely many solutions here, so just choose whichever one comes to you first. Here's our last converting one, the point -2,0. This is another one of those that is on the axes, so when we convert it over into polar form, please just think about where this point lies. The point -2,0 means you're 2 spaces over to the left. Your angle can be thought of as pi, and you're going to count in that direction. So I can say that it's going to be 2 pi. Or if you prefer to use 2 pi as your angle, you can use a -2 as our r value.